Welcome back to my channel Junior Doctors, where concepts made crystal clear. So this is the part 2 of mechanism of breathing. Hope you have watched part 1 of mechanism of breathing. In last video, we talked about how and why the intrapleural pressure is negative. In today's video, we are going to study the actual inspiration process and the actual expiration process and the various movements taking place during this process. So let's focus something in the central nervous system to study the process of inspiration. So as you can see, this is our cerebrum. This is our acute cerebellum. This is our midbrain. This is pons and this is medulla. So in medulla oblongata, we have inspiratory centers. So this is the VRG, ventral respiratory group of neurons, and these are the DRGs. Both have inspiratory impulses. So this sends inspiratory impulses in the vertebral column and they activates somewhere about C3, C4 and C5. Now C3, C4 and C5 will stimulate our acute diaphragm and causes it to contract. Furthermore, they have also tendency to activate now T1 to T11. All these combine and they will stimulate our external intercostal muscle. And you might be knowing that this C3, C4, C5 which is supplying the diaphragm is famously known as phrenic nerve, and the nerve which is supplying the external intercostal muscle is the internal intercostal nerve. Right, so let's see what happens when these nerves stimulates the muscles of diaphragm and the external intercostal muscles. As the diaphragm gets stimulated, it contracts and it will move downward. Right? It is a dome-shaped structure, then it starts moving downward. And these external intercostal muscles will move outward. As these external intercostal muscles moves outward, what happens? The thoracic cage enlarges, and this is known as the bucket handle movement, as if we are holding and taking up our buckets. And due to this, the sternum also moves upward and slightly outward, and this movement is known as pump handle movement. Right? So as you can see, the thoracic cage enlarges and the diaphragm moves downward. Let's recall our Boyle's law, which states that as the volume increases, the pressure decreases. Here comes an important point. As we all know that the intrapleural pressure is about -4 mm of mercury. During the process of inspiration, as you can see, the volume increases, the pressure decreases, it reaches up to -6 mmHg. Similarly, intrapulmonary pressure, which was about 0 mm of mercury, it will also decrease to about -1 mm of mercury. So I can write here also like 759 mm of mercury, right? Now what happens? According to the rule of diffusion, the air which is higher in concentration moves to the concentration where it is low, right? So as we all know that in the atmosphere, the pressure is 760 mm of mercury, whereas inside the pressure is about 759. So as the rule of diffusion, the oxygenated air moves in up till what? Up till when this pressure reaches 760 mmHg. Or we can say from -1 to it reaches 0 mm of mercury. right? So this is nothing but our inspiratory process. It is so easy, right? And these are the pressure and volume changes occurring during the process of inspiration. Now, an important point comes here. As I mentioned earlier when I explained you the muscles of inspiration as well as expiration, we discussed that expiration is a passive process. Now, why it is known as the passive process? Let's focus on that. In our respiratory system, at certain bronchi and bronchioles, there occurs an important structure which are known as stress receptors. Let me show you that with a beautiful buddy. Right. So, this is our stress receptor. When the lungs enlarges and it reaches up to a certain limit, that after that it cannot get expanded, these stretch receptors gets activated, and this stretch receptor will send the signal to the medulla oblongata in the VRG and in the DRG to stop the stimuli. Right, as the stimulus stops, the nerve frequency decreases. So here you can see that the velocity of impulses decreases here also as well as here also. It causes the diaphragm as well as external intercostal muscles to relax. And that's why this process is passive. Now let us focus on pressure and volume changes. As the volume starts decreasing, the pressure starts building up. Right, the pressure starts building up. So, in intrapleural pressure, which was about -6 mm of mercury during the process of inspiration, it will again move to the pressure that is -4, that is the pre-inspiratory pressure. Similarly, the same process occurs in the lungs. Right, it will move from 760 to 0 during expiration. And according to the law of diffusion, the pressure inside the lung is higher. So, the air moves from lungs outside into the atmosphere. But this air which is moving outside in the atmosphere will be CO2 containing because of the internal respiration, which we will study in our upcoming videos. Hope you understood the whole process of inspiration as well as the expiration. More importantly, the pressure and volume changes during both these processes, and the most importantly, you understood why the expiration is a passive process. Up till now, we talked about quiet inspiration as well as quiet expiration. What happens when we are doing a forced inspiration as well as a forced expiration? So, during the forced inspiration, the pressure inside the pleura, which was -4 mm of mercury, might be reaches up to the -7 mm of mercury. And the pressure inside the lungs reaches from 0 mm of mercury to about -2 mm of mercury. This is during forced inspiration. Marked well, we are talking about forced inspiration. So according to the law of diffusion, the air moves inside the lungs, but this will be a very speedy movement of the air because this is the process of forced inspiration. Similar things happens when we are talking about forced expiration. So the pressure which reached up to -7 mm of mercury will reach up to -4, or it will reach up to -3 mm of mercury because this is unforced expiration. Similarly, pressure inside the lung, which was -2 mm of mercury, may reach up to 0 or +1. And you can apply here the law of diffusion. The air moves from the higher concentration to the lower concentration. Similarly, the air inside the lungs is higher, so it will move outside. And in this manner, the forced expiration takes place. Hope you got both the concepts very well. Your concepts of inspiration and expirations becomes crystal clear. But don't forget to subscribe my channel, to share my content to your colleagues, and hope you all will enjoy learning. Thank you and bye bye.